A while ago, I came across a 1950s Heathkit radio, and the radio had a lot of problems. The cabinet was in bad shape, the tuning capacitor was basically falling apart, and there were some other issues, I believe. So I decided to salvage a couple pieces from that. So I got a power transformer, got octal tube socket, and the output transformer. And then I went ahead and I got some extra tube sockets. This I got out of a 1940s RCA. And I got some other ones here, a different variety. So I went and got these, and I decided to build a tube amplifier using a variety of different types of tubes, all the way from the 1920s with this guy up to the 1960s with nuvistors. So with that in mind, I decided, planned out what tubes I'm going to use. So I'm going to use a type 26 in here, type 27 in here, a rectifier in here. I think I'm going to use the rectifier out of the Heathkit, which was a I think it was a 5Y3 or something like that. Got a 6AU6 in here. This is a sub-miniature socket. A power pentode. I think it's a 6902 or 5902 or something like that. I'm going to use in here. And I got two nuvistor sockets. I have the nuvistor around here somewhere. I forget the number of the nuvistor. Basically, it's just a triode. And in the other one, also a nuvistor socket, I'm going to use a DM160, which this is going to act like a basic VU meter. It's not a real VU meter, but the varying intensity of the lights kind of act like a VU meter. I think it'll look cool. Plus, those tubes are extremely small, so what we're going to have in the end is a tube amplifier that ranges from light bulb sized tubes with the 26 all the way down to tiny little nuvistor and DM160s. So with that in mind, I cut out a piece of metal. The original color was brown. I painted this. So I cut out holes for the power transformer here, the rectifier, the 27, the 26, the 6AU6, I think it is, the miniature 7-pin, the sub-mini, and the two nuvistor sockets, and the output transformer. And I also drilled a couple of little holes in here for terminal strips. And then the holes to the outside I drilled because when this is finished, I'm planning on building a wooden frame to go around the outside. Since all the wiring will be done underneath, that wooden frame will probably be something like that thick or whatever to just lift this up with the wiring underneath, and I think it'll look pretty nice. And then I'm planning to put the controls, mount them on the wooden frame down here as well. So, I don't think I'm going to film every minute of building this. Basically just going to be a lot of wiring and soldering, but I think I'm going to go over a little bit the basics of tube electronic design, because I don't know how many people still do that. I'd imagine not many. What I did for this is I decided what tubes I wanted to use. Well, I looked at a couple of older designs for some of it, and the rest I decided what tubes I wanted to use and looked up the data on those tubes and calculated resistor values and everything. This transformer I think is off about, well, the filament voltage is 12 volts, and I think the B plus is somewhere around 350 under the load in the Heathkit, so we'll have to see what it is under our load. I don't think it'll be that different. The filament voltage is going to be the hardest to do because most of these tubes use a different filament voltage. For example, we have the 6AU6, a 6 volt tube. The power pentode, the sub-mini, is also a 6 volt tube. I'm going to hook these in series to get the 12 volts, but I also have to put a resistor in because this tube draws less current than that one. I have to check what I think the DM160 is a 1 volt tube or something like that. I have to check on that. I have to check on the nuvistor as well. The 27 is a 2.5 volt tube, and the 26 is a 1.5 volt tube. So I'm going to have to stick some power resistors in there to drop the voltage appropriately. So what I'm first going to do is install all the sockets and the power transformer, and possibly the output transformer. And then I'm going to work on getting the tube voltages correct, at least on these three, because these are going to be the audio circuits. The nuvistor is just going to be a driver for the DM160. It's not going to be handling any audio. So I'm going to wait until to do these at last. I'm going to do the audio tubes first and see if I can get those working. So I'm going to probably install all the sockets, and then work on getting the filament voltage correct for these tubes, and I guess we'll see where we go from there. So the nice thing about working with Heathkit components is, because they are designed to be kits, either you can buy the kit and assemble it, or you could buy the kit and assemble it yourself, or you could have it assembled at the factory. Everything is screw-in. There's no rivets. I don't think there's any rivets at all in the radio. So to salvage these parts, all I had to do was unscrew them, and basically I have them there then. So it's a really nice feature there. Most other radios, I'm not so sure about the power transformer, but at least on the other components, pretty much everything is riveted in. So if you want to salvage anything, you have to either break the rivets or drill them out. Get these wires in here. I may end up putting some type of tape or something around this, just so that it doesn't rub against the wires or anything. Have to see how that goes. And once I have this in here, I can just screw it back in with the original screws. So yeah, definitely Heathkits are nicer to salvage from than other riveted brands. So these wires here are the input to the transformer. I think this is the filament voltage. That one, just go back to ground. I have to check on that. I think these are the rectifier filaments, and yes, these are the high voltage. So I only have one filament wire. Oh nope, there is another one. I just missed it. Hold on. Yeah, there is two filament wires. This one just got pinched up under there. So, yeah. If there hadn't been two filament wires, if it had just been that this would be like positive filament, and then ground for the filaments would have been regular ground, that would have presented a problem for the Type 26 tube, because that is a directly heated cathode. So basically how that one works is the filament is the cathode. So in order to prevent AC hum from getting into the audio, you have to balance the filament between, so basically ground is center tapped off the filament, essentially, so that when one side of the filament voltage goes high, there's the same potential to ground as when the other side of the filament voltage goes high. If you don't do that, if you just connect one side of the filament supply to ground and the other side to positive filament supply, the directly heated tubes give you AC hum in the audio. Might be problematic. There we go. Alright, so we got our power transformer on. We'll move next to the tube sockets there. Okay, so I've got all of my tube sockets and transformers installed. And before I go any further, I thought I would just make a little comment on the scope and purpose of this. The goal of this is not to build the best or highest power or most amazing amplifier ever. The goal of this is to build an amplifier that basically uses a variety of different tubes to show the evolution of tube types from back in the 20s all the way up to the latest kind of tube, which would be the nuvistor. Yes, I know they did have compactrons, but I'm not sure that I would really want to work a compactron into this. So I know that I definitely could have gone with more powerful tubes like a 2A3 or something like that, but that's not the point here. The point here is to show the transition from the 4-pin UX base with the globe tubes or the large ST tubes, to the smaller ST tubes, to octal tubes, to the miniature tubes, to sub-miniature tubes, and then to the really small nuvistors and the DM160. So, now that I've got all this stuff installed, I guess it's about time to start working on getting the filament voltages correct. So, just a note, for those of you who don't know how vacuum tube electronics work, you can kind of think as the vacuum tube similar to the transistor, with the major differences being one, that they have to be biased a lot differently than transistors. You know, you can get transistors that work off a couple volts, while most tubes need at least 100 volts to work. They do have battery tubes that operate off lower down to like 40 volts or so, but most tubes for electronics like this need at least 100 volts of bias to work. And also the tubes have a filament in them, which transistors don't have. And aside from that, the actual methods of calculating biases between tubes and transistors is pretty similar. You want to get your bias point basically right in the middle of cutoff and saturation to have the widest swing on the output. So, I think I mentioned before the Type 26, the UX4 base there, needs a 1.5 volt filament. This guy here, the 27, needs a 2.5 volt filament. That's the rectifier. I'm using the same rectifier as the Heathkit used, so I don't have to make any changes to that. That uses 6 volts. I don't remember the current draw. That uses 6 volts. These two I'm going to put in parallel with a dropper resistor because they use different currents. And those I'll work on those later. So, this video is already about 15 minutes. I think I'll cut off here and pick up with how far I got on the filament biases in the next part.